So, let us try to link the Haar wavelet decomposition and link these two filter banks. Okay. So, let us look into wavelet decomposition from a filter bank perspective. Usually when people teach filter bank theory, that is multi-rate signal processing, they have portion of their syllabus explicitly on systems, that is multi-rate systems, and then there is also a portion on wavelets, and we will see the link between the two. I think you will appreciate it much better. So, let us start with the following. Let H be this vector which is minus half and plus half. So, I say this index is minus 1, this index is 0. Now, we can think about it as 1/2 time index 0 time index minus 1, it is minus half, and let L be 1/2 1/2, this is index 0 index minus 1. I think you can very clearly see that this is like your high pass filter, H is like your high pass filter, first order, this is like your low pass filter, first order, right. I mean, if you just look at the coefficients, you can get sort of an idea just where we are alluding. Let the sequence xk belong to L2, that is L2 is the space such that the norm L2 norm is basically finite. Okay. Now, let us do the following operations. Let us consider y subscript h of k is h convolved with the sequence x, right, and this is the convolution operator. Of course, people who think about it in computer science, they think it is a star, it is a multiplication, but for us it is convolution. Okay. Now, this is 1/2, directly you can just convolve h with x, this is half xk minus 1/2 xk plus 1. Okay, this is straightforward. Similarly, we have yl of k is the filter L convolved with x, and it symmetrically follows, it is 1/2 xk plus 1/2 xk plus 1. Now, if we keep only the even subscripts, or I would say indices, via downsampling by 2, right, then I would say yh of 2k is 1/2 x 2k minus x 2k plus 1. I think putting it like this is a little bit of an old form of notation. You could put the extra braces, you can say x of 2k, but you know I will just put this as a subscript, sometimes interchangeably, but nevertheless you can just compile this through your head that this is indeed what it is. YL of 2k is 1/2 x 2k plus x 2k plus 1. Now this is sort of familiar if we kind of bring in the scaling into picture and the idea of downsampling and filtering from what we have done through the wavelet decomposition. So let us apply this idea, that is what we just did, to the scaling and wavelet coefficients going from level j to level j minus 1. Now b suffix k j minus 1 can be interpreted as some y h of k, take this and downsample this by 2, right. This is basically y h k is basically a j convolved with h. Now you can think of a k j minus 1 as basically y l of k and feed this to a downsampler. And you can interpret y l of k as some a j convolved with a filter L and then downsampling it, right. This is sort of straightforward. What we have done is basically we have used the identity for linking AJ and AJ minus 1 and AJ with BJ minus 1. This is what we have done. So if you think about it in terms of filtering operations, you can say that you have AJ here, this goes through filters L and H, then there is downsampling by 2, and you have AJ minus 1 here and you have BJ minus 1 here. This is basically like the analysis stage of a filter bank. We have done nothing except that we have sort of interpreted the wavelet decomposition through filtering the coefficients from SKLJ through appropriate filters. Okay. Now we can think about it in a similar way for the reconstruction procedure. Similarly, the reconstruction procedure involves synthesis filters. Let us see how this can be done. Let H tilde be 1 and minus 1, right. I will just index this as 0, index this as 1, and you can think about it as this point I have 1, this point I have minus 1, and I have L tilde as 1 and 1. This is 0, this is 1, just interpret this as 1 and 1, 0 and this time is 1 here. Okay. Now, following the same idea we did before, we will consider H tilde convolved with x, and this is xk minus xk minus 1, and L tilde convolved with x is xk plus xk minus 1. Okay, this is straightforward, just filtering operations. Now, suppose x and y are sequences with zeros in their odd indices. Suppose they are sequences with zeros in their odd indices. Now, H tilde convolved with x is basically x2k when L equals 2k minus x2k when L equals 2k plus 1. We said these are sequences with zeros in their odd indices, right. So, they are already sort of upsampled. You can interpret the sequences as sort of upsampled because they have zeros in their odd indices. So, therefore, if you look at if you have an index with k which is even with k minus 1, it is basically odd, right. So, therefore, one of them would exist. Similarly, you consider L tilde convolved with y indexed as indexed by L, and this is basically y2k when L equals 2k, and it is same as y2k when L is odd, which is of the form 2k plus 1. Now, let me call this equation as 1, this equation as 2. Adding 1 and 2, we get H tilde convolved with x and L tilde convolved with y is x2k plus y2k when L is even and it is x2k negative plus y2k when L is odd. Now choosing x2k as bj minus 1 and y2k as a suffix k j minus 1, we have exactly what we needed from the previous theorem. Summarizing Haar. Summarizing Haar reconstruction, right. So, let me give you the picture. To just recall, you had AL of P is basically AK P minus 1 plus BK P minus 1 when L equals 2K and AK P minus 1 minus BK P minus 1 when L is odd. So, we are sort of set. I think the only point to note, as I mentioned earlier, interpret x and y as upsampled sequences, that is x is, and this is upsampled by 2. So, you have something 0 b minus 1 j minus 1 0 b 0 j minus 1 0 dot dot dot, and y can be interpreted as dot 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 0 a minus 1 j minus 1 0 a 0 j minus 1 0 dot dot dot. Now, I think with this we are sort of set in terms of interpreting this filtering operation. So, we can think of a j minus 1 being upsampled and then going through this filter L tilde, and we have bj minus 1 being upsampled going through this filter H tilde and then combining them to give you AJ, right, and this is basically the synthesis stage. Okay. Now, we can combine both the analysis and synthesis stages. So, what we get is we have these AJs in scale J that goes through some filter L followed by downsampling by 2, followed by sampling by 2 with some L tilde in the first branch, and in the second branch it is basically filtering by H, then downsampling by 2, then upsampling by 2, and then you have H tilde, and then you combine from both the branches and you get AJ. And this is basically our filter bank, basic filter bank with the low pass filters and high pass filters. Okay. And one can extend this at different stages. Now, this is stage say 0, j equals 0, then stage j equals 1, j equals 2, and therefore you can sort of at every point you can think that this you can say that this is, you can expand this out. So, basically there is one stage here, this again can break up into 1, this possibly can break up into the next, so on. You could have a dyadic decomposition, or you could have a binary tree decomposition where you can basically decompose on the other side as well. You can fork here. Okay. Now, you can clearly appreciate the role of the radix 2 there and the downsampler and the upsampler, right, downsampling by 2 and upsampling by 2 and the radix 2 in the Haar wavelet, and then the interpretation of these filters. So, now given any wavelet decomposition, maybe 3-adic or 5-adic, you can kind of sort of construct the filter bank equivalent representation. Okay. So, I think this completes filter banks and wavelets. And what you think of how good a wavelet is can be thought about and interpreted using the Fourier transform. So, that is the reason where you have this notion of filter, that is wavelet coefficients being filtered through appropriate filters, and you can see the signature of the filters via Fourier analysis. Okay. So, both of these are sort of coupled. So, with this we are towards the end of wavelets. We have completed wavelet discrete wavelet transform, basically the decomposition, reconstruction, certain properties and interpretation, and linking them to filter banks. Okay. So, this is by any means not fully comprehensive. I mean, one has to go through harmonic analysis for a very rigorous treatment on wavelets, but at least it will give you a very good feel from engineering perspective how to go about constructing the transformation itself, starting from the definition of multi-resolution analysis and then building the necessary tools. Okay. So, I think with this we are going to stop here.